All right, so we're going to talk about space cyber. This is going to be really interesting. I want everybody to take a quick second. I want you to, you don't have to close your eyes, but I want you to think about, waking up this morning. Imagine your phone not working. You can't get directions. None of that works. No rideshare apps. You stop at an ATM. You try to get money out of it. The transaction gets denied. You try to call your family. That's down also. All these things come from space. GPS signals, synchronization signals, all that stuff goes down to those devices and are responsible for that. So imagine now that those same signals that are coming down are also responsible for timing signals also for LEO constellations. So now you're not just talking about our terrestrial-based systems, you actually have your low Earth orbit systems that are also going to start losing synchronization. And all of this would not be coming from like a simple bug, a glitch, or anything. Think of this as a situation where somebody launched a cyber attack. This is something that could be really possible. And in some ways, this is something that has happened before. So I want everybody to think back a couple years, think about the war in Ukraine. I'm the clicker guy. There we go. In 2022, Russia invaded the Ukraine, and hours before that invasion, the commercial satellite network Viasat was hit. Thousands of modems in Europe were bricked. You had schools, hospitals, even wind farms that went down. All of them lost internet. And this wasn't something that was targeted. This was something that was launched that would hit anything in that region. So this was something that was done by whatever actor it was to target systems that were being used by the Ukrainian military. This is something that was strategic. This was something that was coordinated. And this is something that was cyber warfare. So what's this all have to do? A little background on me. I'm Anthony. I go by Coin. My background is electrical engineering. I'm a bit of a nerd. But I'm an officer in the Air Force. That is my day job. I'm also a professor at the Air Force Institute of Technology. It's the Air Force's grad school. That is my day job. My night job, I call it, is I work on offensive security tools, and I help run a security consulting firm. But I like hacking. That's really what I enjoy doing, so I'm happy to be here. But I'm not really a space guy. So I've kind of like stumbled into kind of a weird area. My background has been, originally was doing electrical components, electromagnetics, radar, and then I stumbled into hacking aircraft of all things. So turn back the clock until 2016. I walked into a fighter squadron and they looked at me and they're like, you did some weird things at one time with cyber. How about you come hack the F-22? And it was the coolest job I can possibly imagine. So my background is actually on fighter aircraft, hacking those. So I've done work on the F-15, F-22, F-35. Move forward a little bit, a couple years. I end up in Wright-Patterson in Ohio, going to school for my doctorate, which I just finished. Thankfully, I don't have to sweat anymore. But I got to work on some really cool research using machine learning to detect malware. And some of this stuff is what I'm going to talk about is stuff that we're going to try to apply onto satellites. So one other thing that I want to talk about, another thing that I had an opportunity to do, I also have a background in the intelligence community. I spent about 4 years at the National Air and Space Intelligence Center. So a lot of the stuff that I look at is also from a threats perspective. So not just, what's happening now, but what can our adversaries do, or what could they do in the future? So, satellites, aircraft. In reality, there's really not a lot of things that are different between the two. You remove that pilot, and an aircraft and a satellite really aren't that different. I mean, sure, one's flying, one's in space, one shoots missiles, the other one doesn't. But you also have protocols in these things that are very similar. Take 1553, for example. That is a protocol, a bus protocol that is in both of these that was designed in the 1970s. So that protocol was not designed with security in mind. It was designed to be reliable. So reliability is something you're going to see across a lot of things. Because last thing you want to do is be flying an F-22, pull a stick, and then the aircraft doesn't respond because it's got to decrypt a message or do other things. They want to just get that information out there as fast as possible to make sure the pilot gets an instant response. And because we try to reuse as many things as possible, the same bus protocol is also instantiated inside of satellites as well. So in my job, my day job is, like I said, I'm working with graduate students doing research. One of the really cool things that I get to do is work with a flat sat. So this is literally a satellite laid out flat, is the way you can think about it. So it is a satellite component, all the hardware, all the same real flight hardware. It has FPGAs, a flight computer. It has reaction wheels, batteries. We don't have the solar panels hooked up because we're inside, but we have every piece there. It has the real flight software, so it's running NASA's CFS. That's their flight software system that they have that's open source. That is loaded onto this box as well. We get to look at this device as a way of evaluating security on satellites. I'll give you a hint, there's no security on satellites. Big surprise. But we're trying to find ways that we can attack it and also defend it. Once these things go up in the air, there's no changing things. Like, you can't just stroll up to a satellite and replace a board. It doesn't work that way. Doing software updates on satellites, also extremely difficult. You're having, in the best of cases, you're hundreds, if not thousands, or in cases of like Voyager, you're billions of miles away, trying to push a package up there with hopes that it doesn't break. So we're exploring ways so that we can build these things to be secure. One of the really interesting things, like I talked about, is 1553 is built into these satellites. Also has other legacy protocols, so you'll see like Modbus, other like bus protocols that allows them to share information. Inside of these, they're running, regular open source packages, like you can imagine. Picture, them in a dev environment, pulling down open source projects. They're pulling things down from GitHub. They're compiling them, and then they're going to push it into the satellite. That software package is what ends up in there, and that's what we're evaluating. But remember, all these things that happen, all that dev stuff, that isn't happening in space, it's happening on the ground. So the ground ends up being one of the areas that you want to target, because you can obviously go hit the satellite once in space, try to break all the squiggly lines and beeps and signals that are going to it. But really, the ground is really that weakest point. You have components and you have software that go onto those devices. So, we're going to talk about ransomware. Now, I'm sure everybody's like, what does this have to do with space? So, bear with me for a second. So, imagine you have a satellite that's being developed, like the software package is being developed on the ground. That entire system really is just a computer. And that computer is going to be in space. A little expensive, a little hard to get to, but it is just a computer in space. Now imagine if we wanted to put ransomware on one of those devices, what would that look like? So this was a really interesting project that I had a student work on over the last about 2 years. One of the questions I got asked was, what does ransomware look in space? If a ransomware ended up on a satellite, how does that actually look? Which is fascinating because, you have your normal systems on the ground. You have Linux, Windows systems. You can encrypt those and ransom those off. But actually, ransoming off the satellite is kind of a different problem. If I just encrypt everything on the satellite, I can't really ransom it back to the target. So I got to be very careful of actually what I am ransoming. And the reason we kind of focused on this is because ransomware is a big problem. I'm sure a lot of people have seen it with their clients. I just pulled some recent numbers that are a little crazy, and it keeps getting worse. But $57 billion is what they're expecting this year. That's not just like ransomware payments. Think about all the other losses. So you have downtime, you have reputation damage, you have just all these things that you have to worry about. Recovery costs, reputation damage, like I said, legal costs, regulatory fines, and then lost business. People may never come back to your company. One of the things that I wanted to also point out for ransomware is, how do you rebuild these systems? So typically, if you have a ransomware hit on a system, one of your options is just, I'm just going to wipe it and start all over. I have a backup. In a satellite, you really don't have a backup. When a satellite gets encrypted, you're not just losing just the satellite, you're losing capabilities. So when that capability goes down, there's a detriment to whatever mission it's trying to support. That may just be internet through Starlink, or it may be an intelligence capability. So those are really important things that we need to protect. But what I want to focus on for this is, how do we get that ransomware onto this device? So we chose ransomware, obviously, because it's one of the most used things that are being done right now, but also it's a interesting business model to apply to the situation. Ransomware is also, quite lucrative if you're the bad guy, so it was kind of interesting to look at this. But let's take a step back when we're looking at ransomware, and let's take a look at MGM. I like using MGM as an example. One, because it's MGM and it's ransomware. So I also lived in Vegas for like 7 years, so they've taken a lot of my money. So back in 2023, they were hit with ransomware. What's really interesting about their hit was the way it kind of all occurred. If you're not too familiar with it, this took down their hotel check-in system. It took out slot machines, digital card systems, even like parking. So people couldn't park their cars or get into their rooms. It was a mess. So this entire attack ended up taking about 10 days for them to recover from. So they shut down their entire operations for 10 days. Eventually, like halfway through that, they're like, oh, we can just take cash. We'll figure out a way to take cash. We have some slot machines that still take quarters. Table games can still take some cash, but everything else got shut down. In just those 10 days, they lost $100 million. So that's big money that they lost because of this. And the ransom that was being asked of them was $15 million. So, if I was a gambling man, I probably would have taken the 15 over the 100. But, that's something they didn't know. They thought they could survive it all. Interesting about that is, a few weeks prior, Caesars also was hit by the same thing, but they decided just to pay. So kind of interesting how they took that approach. But this is kind of like the state of ransomware right now is, you either lose 9 figures or you pay a smaller amount and hopefully you get your data back. But really, ransomware, at least the guys that are running these operations, it's in their best interest to provide your asset back to you. If they just encrypted everything and somebody paid the ransom and they didn't give it back, that's bad for business for them, right? They have their business model they're trying to support. The customer may not be the happiest customer, but they do want their stuff back. So this was kind of the things that we were looking at for satellites. Well, if I'm going to encrypt a satellite, I need to be able to return that device somehow. So if we're able to take down, a billion-dollar company, why can't we take down a satellite? So for this, let's focus on CubeSats. CubeSats are small satellites that just about everybody can put up. They're very, very cheap. They're typically running like NASA's CFS. It's an open, like I said, it's an open source software. Anybody can use it, which also means anybody can look at vulnerabilities in it. So they can reverse engineer and start looking at ways to apply, ransomware into a satellite. But one of the important things about CFS is it really isn't designed with security. It's not, we talked about containerization, Kubernetes, all these things don't exist in space. You have systems that just assume everything's trusted. Like I talked about, 1553 is a protocol that's being used in both satellites and aircraft. Everything that gets transmitted on that bus, everybody assumes it's trusted. So if I put bad information on that bus, anybody's going to grab that information and assume it's good. So I can pretend to be, an altimeter. I can pretend to be speed. I can pretend to be a weapon on that bus. And everybody's going to trust whatever I'm saying. That's just the way the protocol's designed. Same thing on a satellite. So with all that knowledge, we decided, why don't we try to put some ransomware on it? So the way we kind of approached it at first was probably not the best plan. We decided, hey, let's just encrypt all of the flight software. Let's go after CFS and see what happens. So you can encrypt everything pretty easily in their flight software. That flight software, once it goes down, shuts down the entire satellite. You end up not being able to do commands, there's no telemetry, and there's no recovery. And that last piece is probably the most important one. If I'm trying to ransom that satellite back to somebody, it's kind of important that I can give it back to them and collect my payment. So that was kind of a failure at first. But then we stopped and thought, okay, what if we strategically target some of these files? And the way CFS is designed, you have like applications, and all the payloads are built through applications. So you can take one of those applications, take their folder, and you can encrypt that. So once that's encrypted, you still have the functionality of the satellite. It can still orient itself, it can still get commands, but the capability of the satellite, its real purpose, that isn't usable anymore, and that's a big impact. So you're not necessarily taking out the entire satellite, just the most important component, which would be whatever its mission, its payload is. So that was very successful. We were able to recover data, we were able to do all those things, collect bitcoins, do the reasonable thing. But the interesting thing for this is it isn't all about chaos or destruction. This is something about being very targeted. Because easily, if you want to just take out the satellite, there's got to be easier ways than putting ransomware on it. We have anti-satellite weapons. We have other things that we could use at our disposal in trying to do it. But this was kind of looking at it from a perspective of what does this look like if we have the commercialization of space? Not every asset that's going up there is going to be owned by a country. You have companies, small companies that are putting up assets as well. So for us, this scenario was very successful, which is good. But then we kind of stopped and thought, how do I get that in space in the first place? Sure, I can put ransomware on there, but actually delivering that payload, that's a whole other set of problems. So we kind of took a step back, decided to look at, what are the easiest routes into a satellite? One of those being supply chain. So as you can imagine, satellites are built by companies, especially the commercial ones, that are trying to save as much money as possible. So they're going to buy items from multiple vendors, coming from multiple countries. All those items are coming in. If you end up with a bad component in that supply chain, that's a big problem, because you can't go up there. You're stuck with that. Same with software. You're putting up a satellite up there, and you're kind of locked in with whatever software you put on it. So once that's up there, you're locked in. Every wire, every chip, almost every line of code. You can still fix some lines of code, but most of it is locked in early on once it leaves the pad. Once you're up in space, that's it. So for you to be able to do updates on that, you either need to go up there and physically touch the satellite, or you do software updates. Can't fix the hardware, but maybe fix the software. When you're doing those software updates, it's really like surgery. You're fixing things here and there, but you're not able to flash the entire thing and rewrite all the code. For that, a good example, since we're all here at Kennedy, we have Voyager. I'm sure everybody's heard recently about Voyager, the interesting situation it got in. If you're not aware, so 1970s, this was launched, 77 to be exact. It is 15 billion miles away. So for you to be able to talk to Voyager right now, it is taking you 22 hours to transmit a signal to it, and then 22 hours back. So that is a long time to be able to do something. And last year, one of the chips went out. So they had telemetry data that started coming back that was garbage. They weren't able to do anything with it. And with that, they were like, oh, we lost the mission capability of Voyager. How do we fix this? And the fix for it was rewriting all of the flight software so it redistributes itself around essentially the broken memory. Because all of the memory for Voyager is like 1 megabyte. So you can imagine you don't have a lot to work with, especially if you start having failing components. But this is what software updates look like. Maybe a little bit further away than what we're doing for like low Earth orbit, but still. And I wanted to like stop and like put an analogy of what this would actually be. Like, what is it actually like doing a software update on a satellite? So obviously I did the easy thing and I went to ChatGPT. So I asked it, like, what if you had to tell me what this was? You're dealing with 1970 technology. So really it's like not performing brain surgery, learning how to perform brain surgery while somebody teaches you with a VCR, a walkie-talkie, and they're on another planet. So combine all those things together, and that's what it's like. So it took NASA, really smart people, 5 months to be able to recover the basic engineering data, and they're still bringing it on today, and they had to do this one function at a time because of that delay. So let's focus back on those CubeSats now. Let's move it a little bit closer to Earth. So now you have that CubeSat that's in space. It's built by a startup company. They use commercial off-the-shelf components, they put them in there, they launch it in space. They may or may not have redundant systems in there. They may not even have remote update capabilities, depending on how they design this thing. Because typically when you're in low Earth orbit, you're not planning on being in space very long. It's cheaper just to launch another satellite than it is to fix the one you already sent up. So now imagine, they purchased, we'll call it a altimeter from a country. They also have processors, memory, radios, sensors. But that altimeter, has a tiny board in it, maybe has a low-power ARM processor. They test everything on the ground. But what if, you run through all your tests, everything checks out. What if it's got a piece of code in there that waits for it to be in space? And then it does something, it executes. It's on that bus that we talked about. Everything's trusted on the bus. Now it's putting information on the bus. It's saying, hey, look at me. I'm now the radio. I'm now the flight computer. I'm the bus controller. I own everything. Or I'm just going to put information on that bus, and once you start spamming that bus, nobody else can communicate on it. So now you've shut down the satellite. So you have that supply chain that's built into this as well. And this isn't something that's, surprising. We've seen this before. We've seen network gear with baked-in backdoors. We've seen software updates that have things in them that probably shouldn't have been there. So this isn't something that's just outrageous. It's just something that we're applying that's ground-based into space systems. A good example for that would be XZUtils. So this was a small piece of software used for compression in Linux systems. Not flashy, it's nothing special. It just runs in the background of Linux. Last year, they discovered a backdoor in it. Luckily, it wasn't deployed yet, but it's a really interesting story. The person who was responsible for this spent years building up their reputation, building up their ability to interact with these individuals, and slowly put in everything they needed in place, and eventually was able to kind of be in charge of all the security that was associated with this project. And as part of all that, disabled some protections and then uploaded inside of that part of their build process a backdoor. And this backdoor would have given whoever had access to it, access to whatever system. That could be servers, that could be Linux systems, that could be ground stations, you name it. But it would have been associated with SSH. So once that got in there, though, they could have wreaked havoc. Luckily, it all got found by accident. The small changes that were made degraded the performance just enough that somebody noticed, and they went back and looked, and were like, hey, this looks a little funny. Maybe I should take a look at this and figure out what happened. So this was a silent entry point that was just lucky to be caught. Now imagine, this gets loaded into whatever project, and then when they're doing their build process for a satellite, it ends up in there. So now you have a rogue piece of software that ends up in a satellite going up into space that you may not realize that's there in the first place. So really, when it comes down to it, when these supply chains break down, it's more than just a global problem. So how do we fix this? This is one of the things that I constantly ask some of my students. It's great to break things. I love to break things, and I'm sure everybody here loves to break things. But we also need to defend them. So one of the interesting ways that we're exploring a way to defend satellites is looking at the commands. So you have set commands that go up to the satellite, typically through a ground station. So you're setting up those commands, and maybe one of those commands is going to be malicious. So how do you stop that? Do you filter all the commands from the ground? Well, then what if it's coming from a component already in the satellite? If I'm only filtering from the ground, I'm only looking at half my commands. So one of the projects we worked on was looking at, hey, can we categorize commands, apply machine learning to the problem, see if we can kind of predict what the next command would be. And then if something is out of the ordinary, we can flag it, and we can either drop whatever that command is, or we can relay it back down the ground and then see if they can go do whatever they need to do for incident response. And it's something that seemed to be pretty successful. There is one problem, is applying machine learning into space is a hard problem, extremely hard problem. You're limited on space, you're limited on how much computing power you have, and oh, by the way, whatever you apply it to probably already has to be up there and you have to update it. So not an easy thing to do, but these are some proof of concepts. So this is one of the things that I love to do, is just kind of throw out some crazy ideas and see if any of them stick. So applying machine learning to the problem sort of works. Another one to look at is, well, how do we evaluate things before they go up? So before our hardware ends up in space, can I evaluate it? So looking at some frameworks to be able to do that. And then another one that I really like, and it was brought up earlier, I can't remember who brought it up, but it was Kubernetes and containers in space. So being able to isolate the systems. So kind of turning it into a zero trust environment. I know it's a dirty word, but zero trust. But that's essentially what you're trying to do, is you're trying to assume that everything on the satellite is not trusted. There has to be some level of encryption, some level of authentication, which is nice because if you can't assume every piece of data you have, then you do have the ability to isolate and kind of recover from an event. Otherwise, if a radio gets hijacked, for example, or a sensor starts lying, you're going to trust whatever data that's coming out of it. It'd be nice to be able to say, I think this data that's coming out of this sensor is bad. Let me isolate it and use other sensors instead. So this is kind of where I'm going with a lot of the research. And kind of where I see a lot of the space stuff going is you kind of have to look at it as a different set of problems. You can't trust a single component, because at the end of the day, you're going to end up with a single board that may get compromised in your supply chain, and you need to be able to recover from that. All right. And thank you. That was me rambling a little bit on about satellites and security. Thank you guys, everyone. I'm open for questions if anybody has any questions. So, yes.
Okay, so I have kind of a multi-part question here. Okay.
Oh.
All right, so I have kind of a multi-part question here. I know you're talking about different protocols in use. Let me see, is that going to work? Okay, better. So I was thinking about your mention of Modbus. I know that Modbus, at least in basically all uses that we have currently, they're tending to go for the normal unencrypted one, right? Given what you said about responsiveness with 1553, I have a feeling that's also unencrypted, just based on the speed requirements. So what that made me think of, and you can relate this to aviation a little bit more if that helps, but in OT, you have a hard outside, and then the inside's where all of your weaknesses are. I have a feeling that on satellites, a lot of the protocols are probably very insecure if they're not encrypted, stuff like that. And that might be why you brought up containerization as a solution here as well. What percentage roughly would you say is the unencrypted traffic on one of these devices?
On a satellite?
On a satellite.
Like 100%. Everything within the satellite is unencrypted.
Yeah.
Obviously, you have your signal that comes down from the satellite. Those are encrypted. They used to not be, which was funny, years ago, but definitely encrypted nowadays. All that stuff, yeah, very hard exterior, very, very soft in the middle.
Yeah, okay. So my next question kind of relied on that. So I was hoping that I was a little bit right, otherwise the other two were just going to be bad questions. What would you say the risk is of passive access or selling to a nation state access broker type stuff versus ransomware would be for a satellite?
So ransomware from like a nation state perspective?
Yeah, instead of like a ransomware, more of like access broker selling access to the satellite.
Oh, interesting. Okay, so selling access is what you're talking about. That'd be an interesting concept. Because then you'd have to hijack the satellite, and then obviously there's issues with that. You'd have to have complete control, and you'd have to cut off control for somebody else. And then you have to worry about the fact that you're hoping that they can't recover it. I never thought of that problem. That's a good, interesting way to look at ransomware a little differently.
Okay. And then the last one was, I imagine that there has to be some key that the satellite itself has on it to encrypt the signals that it sends, just based on how things work. What's the risk of an attacker getting access to a key like that? And is there anything in place that cycles that every so often that you have, or that typically is set up to prevent any kind of key theft?
I'm going to pull my government card. That's one I can't answer.
Got it. Understood. Thank you.
All right. Who's next? That guy? I love public speaking, so this is terrifying to me.
So I understand that equipment and software, mainly going up for satellites, is designed to be reliable first. So usually we're looking like maybe 5-10 years back when we're looking at software and hardware being put up. How do we develop the patches and security for when we discover vulnerabilities like tomorrow or a couple days later? How do we address that in the chain going up before it's launched and then
Yeah, that's a really interesting
carried
problem.
on after?
So if you're not familiar with like even aviation, very similar to satellites, is, I'm gonna use, I do a lot of aircraft stuff. So think about the F-22, for example. That is, 1980s, early 1990s technology. Didn't field until early 2000s. You end up having hardware that is a decade plus old because of the reliability piece. And you start development so early. So by the time it gets fielded, it's already, out of date essentially. So then you add in the problem of I'm fielding a piece of hardware with a software suite, and now I'm fighting vulnerabilities. How do I go about addressing that? So from like an aircraft and like a satellite perspective, they really don't, to be honest. You're relying on the fact that you are essentially an air gap network in a lot of cases. 1553 is a good example. It's still being used in all of these things. It can be jammed, you can be hijacked, all those things, but it's in a place where it's kind of hard to get to. You're already gonna have to have a compromised device. And you can't really afford to delay the signal, because if I don't have that responsiveness, at least in an airplane, there's a problem. So it's hard to address. Software can be updated, especially like on aircraft, much easier. Satellites is a whole different game. You're hoping that those individual components have good software packages. So going back to that flat sat that I have, we've looked at quite a few of the components, one being like the reaction wheel. That has an ARM processor on it, and it's running free RTOS. So it has like its own software. So each component now has its own operating system. So you don't have one universal operating system. You have like dozens of them all across this, and everything's communicating. So now, hoping that every piece of hardware and every piece of software is secure becomes a really big issue very quickly. Did I answer your question? Sort of. I'd say they're both insecure. Because you have CFS, which is free. You're going to find that on your cheap satellites. Open source. Anybody can look at that source code. And then you have, your expensive assets that are probably running something that's more proprietary that nobody's probably cyber tested ever. So they're two different types of problems, really. So who's next? And I think he was after him, or either way.
Great talk. I appreciate you coming out and sharing your awesome knowledge. One question, and maybe this is like an inter-talk type question, but one of the things I picked up on a prior talk was essentially space operators looking at their feeds and seeing something going wrong and not assuming hackers, poning the space box in the sky, but more so something going wrong. In your experience or research, have you noticed like people getting into these systems and trying to do evasive type maneuvers to basically call back and say, hey, all systems are normal, nothing to see here?
So from like a test perspective, we've done this. So we've looked at aircraft. Aircraft's a good example. It's much easier for us to access. You have a pilot that's interacting with it. And if they don't know it's a cyber attack and they think something's wrong, they're just going to assume a component's broken. If I try to go left and I can't, and then it's like, oh, something's broken there, or my radar's not working, or my radar warning isn't working. Their first thing isn't going to be, I'm under a cyber attack. I had an engineer in one room say that, be mean a little bit, but said probably the dumbest thing I've ever heard is, well, why don't we have like a light in the cockpit? Like, what do you mean a light? It's like, it tells you if you're cyber secure or not. And I'm like, you know how many things are in this cockpit? The last thing they're going to care about is if I'm under a cyber attack. And the reason was the best. So one of the pilots stood up and he's like, how is that useful to me? And it's a good point. Like, if you're under a cyber attack and you're flying an aircraft, how's that useful to the pilot? What can he do? He can't do anything. Can't turn off the plane while he's flying it. Can't go into a Linux terminal. He can eject the aircraft, and that's about it. So, like, boot it into safe mode. So it's an interesting problem because there's the primary mission, whatever that primary mission is the most important thing at the end of the day. So for them, if all those things appear to be broken, they're just going to assume it's broken. So now that changes things a little bit. You can't just like silently modify a little bit. It's like you either take out the entire, whatever that thing is, or you got to be really, really crafty in whatever you're doing. So at least that's been my experience. I haven't done a lot with operators on satellites, but I'm assuming it's going to be very similar. Is if they're getting bad telemetry data, they're just going to assume a component's bad. That's probably going to be the first assumption. And it sounded like that was their experience as well. So that's a good question. I think. The cyber secure light in an airplane? Yes. I'm patenting it.
Yeah, so I've been tracking other influences on satellites, basically having the 14-year weather cycle. We had, let's see, one cycle we had cars having major problems because the car chipsets were at the frequency of some of the gamma rays, which was interesting. We've seen it time and time again. We saw loss of NTP for a total of 1 hour, which actually impacted systems and whatever. Are you looking at the radioactive, all the particle impacts that could be used as a cover for a compromise?
Not yet, but that's the beauty of my job. So those are interesting things that I want to push problems to students.
I'm only mentioning that because I noticed that Elon sent something up into space and a bunch of stuff fell out. So came back to Earth very quickly.
Oh, I bet. But yeah, the beauty of my job is we do research. Like, we are part of the Air Force, but our mission is to train students and do security-based research. And obviously, satellites are a little important. Just a little bit. Just a little bit. Yeah. But, focusing on like external things is also extremely important when it comes to interacting with those satellites. Causing a bit flip shouldn't be a big deal, but depending on what the component is, it could be a very big deal. It could be the difference of, being at an RPM on your reaction wheel of, 1,000 and, 10,000, depending on what it is, right? And that's a big deal because, like mentioned earlier, you have a limited amount of delta V. And once that goes away, you're done. That's all your satellite can really maneuver.
One more question. From a networking standpoint, looks like we're going to be running IPv6 in space.
Yes.
Based on an IETF presentation last October, it looks like it's moving very quickly. That seems like an update to a bunch of technologies. That also looks like a real problem in some cases.
Yes, a lot of things are moving to IPv4, 6 flavor-ish things. Like right now, like especially on like the aircraft side, you'll see like 1553 wrapped in Ethernet, or you'll see AFDX, which goes through Ethernet, so point to point,
Right.
which is starting to get really close to Ethernet real quickly, which means a lot of the stuff that we can do on the ground without having too much knowledge, we can then apply to space assets, which is terrifying. Because now the fact, you know, my advantage is not a lot of people have a satellite sitting in their basement, but a lot of people have, you know, a switch, a couple Ethernet cords, maybe a computer, a Linux machine or something that they can plug into and exploit. So
Yeah, the issue is that they're allocating or will be allocating IPv6 addresses, not IPv4 addresses to the moon. So that's a whole nother problem.
yes, very much
Anyway,
so.
enough problems for me today.
Yeah,
Here.
I love problems.
When you when you are defending parts of a satellite, what would you say has precedence? Because I feel like, for example, the communications and how it contacts the ground would probably be one of the most valuable parts.
That's a hard question. I'm gonna use a standard Air Force answer. It depends. But it really does. So remember, the satellite, the most important thing is its mission. But if I take out, being able to orient itself and recharge the solar panels or the battery through the solar panels, that's a big problem, right? So in reality, like everything's important on a satellite because there's no fixing it once it goes bad. You know, once you lose power, there's no charging yourself back up again unless you get really lucky and you happen to point towards the sun again. You have to kind of protect everything equally because if just the functionality of the satellite goes down, that's an issue. Now I can't orient myself. If the payload goes down, now the mission capability of that satellite, that's now down. And those kind of have to be weighed equally, which is difficult because you're limited on everything in space. Weight, you have a limited amount of power, space, obviously. You can't have a massive satellite that's the size of like a server farm. It's just not practical either. So that's why looking at components like FPGAs is great because they can be repurposed. But yeah, I don't have a good answer for that one. Defend everything. Just make everything a container. Problem solved.
Okay, thank you.
Right. Any other questions? Nope. All right. Oh.
Hi. I have a question. How do you deal with the old satellites and the legacy satellites in space? I mean, we shoot out satellites every week. I'm just saying every day, all over. Like, how do companies, space agencies and nations deal with all the space debris over there right now?
So for me, all of the work I've done has been on CFS, which is nice because it's all open source. So anything I talk about from that point on is now me speculation. From my opinion, how do we deal with security on like legacy systems? Mm-hmm. We don't.
How do you discard them?
We just hope that whatever's talking to it is secure. I know somebody on stage earlier said that one of his legacy systems was, MS-DOS. And how do you secure that? You don't really. You hope the network that it's on is secure, and you hope that it doesn't get compromised when it's talking to a satellite. So really, you just have to have good, normal network security in that case. Because there's no going and reverse engineering the satellite that's up there, that's been up there for 20, 30 years. Its software is what it's going to be, and that's really not going to change. So you just have to secure that link that goes up to it, because hopefully nobody else can gain access through your network to talk to that satellite. And that's all speculation. just to clarify.
Okay, so you don't discard them, you try to fix them kind of thing.
I'm not looking at a way, that's not really my area of research, at least. I'm focused on like satellites and kind of, I'll call it next generation stuff with whatever CFS is going to evolve into. That's really where I'm focusing a lot of my research at the moment. But it is a problem, and I really hope somebody's looking at it because...
And now they're talking about Kessler's effect and stuff like that, so I'm like, I don't know. Just reading.
Yes.
Thank you.
Thank you. All right. I think I'm done. All right. Thank you, guys.